Hey guys, Mr. Antonucci here, and in this video, we're going to go over some more critical skills for the AP Stats exam. We're going to look at how to simplify probability as well as random variables. I highly recommend that you download the PDF that goes along with these questions so you can work through them as you watch the video. Grab the link down in the description for that. All right, now let's jump in. Number one, a regional transportation authority is interested in estimating the mean number of minutes working adults in the region spend commuting to work on a typical day. A random sample of working adults will be selected from each of three strata: urban, suburban, and rural. Selected individuals will be asked the number of minutes they spend commuting to work on a typical day. Why is stratification used in this situation? Part A, to remove bias when estimating the proportion of working adults living in urban, suburban, and rural areas. B, to remove bias when estimating the mean commuting time. C, to reduce bias when estimating mean commuting time. So here's the thing, stratification is never used to remove bias. So we can eliminate A and B, and it's also not used to reduce bias. It is used to decrease variability. So this is choices D and E. D says to decrease the variability in estimates of the proportion of working adults living in urban, suburban, and rural areas. Or E, to decrease the variability in estimates of the mean commuting time. Well, to ensure subgroups are represented and to reduce the variability of the overall estimate by grouping similar units, that's why stratification is used. So that's going to be choice E. We want to decrease the variability in estimates of the mean commuting time for that entire region, not those subgroups individually. Number two, there were 5,317 previously owned homes sold in a Western city in the year 2000. The distribution of sale prices of these homes was strongly skewed right, with a mean of 206,274 and a standard deviation of 37,881. If all possible simple random samples of size 100 are drawn from this population, and the mean is computed for each of these samples, which of the following describe the sampling distribution of the sample mean? Well, notice they all have a mean which is the same as the distribution, 206,274. So we can't eliminate anything there. But since the sample was 100, which is greater than 30, we can apply the central limit theorem, which means that the sampling distribution of the sampling mean is going to be approximately normal. That's going to eliminate D and E. Then we need to calculate the standard deviation for the sampling distribution of the sample mean. If you don't remember it, it's on your formula sheet. So here I pulled up the formula sheet. You can see that the standard deviation is the standard deviation of the population divided by the square root of the sample size. So we could simply type in the standard deviation divided by the square root of the sample size, which is square root of 100 or 10, and you get 3,788. That would be choice A. Hey, I hope you're enjoying this content. If so, please go down below and like this video. Number three, a random variable X has a mean of 120 and a standard deviation of 15. A random variable Y has a mean of 100 and a standard deviation of 9. If X and Y are independent, approximately what is the standard deviation of X minus Y? Now, the formula for combining standard deviations is not on the formula sheet. You just kind of have to know how to do this. But when you add or subtract standard deviations in this context, you have to take the square root of the sums of their variances. In other words, you take the square root of the standard deviation of the first one, so 15 squared, plus the other one, which is 9 squared, and you get 17.49 blah, blah, blah. Closest one there is 17.5. Now, some people might ask, well, why are you adding instead of subtracting? Well, two things. If you subtract, you could end up with a negative under the radical. In other words, if they asked what is the standard deviation of Y minus X, you would have a negative. Also, when you are combining two random samples, you have to account for the variability of both of them, and that's why we add instead of subtract. Whether we add or subtract, you still have to add when calculating the combined standard deviation. Number 4, which of the following pairs of sample size n and population proportion p would produce the greatest standard deviation for the sampling distribution of the sample proportion p hat? So remember from the formula sheet, the formula for the standard deviation. It's right here. So square root p times 1 minus p all over n. So this is largest when n is small because you're dividing by a smaller number, and p is close to 0.5 because the closer p is to 0.5, the closer the numerator is to 0.25, which is the largest it would be. We want the smallest n in the value closest to 1/2 for p. So that would be choice E. Now you might ask, why can't you do it with p close to 1? Well, as p is closer to 1, 1 minus p gets closer to 0. So you're kind of in the same situation as when p is close to 0. If p is close to 0, then 1 minus p is close to 1. And you have a number close to 0 times a number close to 1, which is going to be really small. Now, if you're finding value in me walking through these review problems, I would ask that you hit that subscribe button. We're doing a big push for 1,000 subscribers before the AP exams start. So if this video helps you, I'd greatly appreciate your support. Now let's get back to it. Karen commutes to work, and her commute time is dependent on the weather. When the weather is good, the distribution of her commute times is approximately normal with mean 20 minutes and standard deviation 2 minutes. When the weather is not good, the distribution of her commute times is approximately normal with mean 30 minutes and standard deviation 4 minutes. Suppose the probability that the weather will be good tomorrow is 0.9. Which of the following is closest to the probability that Karen's commute time tomorrow will be greater than 25 minutes? Here we have to consider a couple of things. The probability that her time is greater than 25 minutes depends on two things, whether the weather is good or whether the weather is bad. Well, there is a 90% chance for good weather, which implies a 10% chance for bad weather. So what I'm going to do is, in the inference table here, I'm going to go to a normal distribution with mean of 20 minutes and a standard deviation of 2. And I'm going to look at the cumulative probability to the right of greater than 25. So that's a little over 0.6% chance that she's going to have a commute that's greater than 25 minutes if the weather is good. Then what we're going to do is calculate the same thing, except do it for if the weather is bad. So that's 30 minutes for the mean and 4 minutes for the standard deviation. Now the mean is 30 and the standard deviation is 4. 25 minutes is more than one standard deviation below the mean. So if I'm looking at the probability to the right, it makes sense that it's almost 90% because I'm way below the mean there. However, we have to multiply that by 10% because it's a conditional probability. There's a 10% chance that the weather is not good. The other one we have to multiply by 0.9 because there's a 90% chance of good weather. This is the probability that her commute is going to be greater than 25 minutes if the weather is bad, which is a 10% chance of bad weather. This is the probability that her commute is going to be greater than 25 minutes if the weather is good, and there's a 90% chance that the weather is good. So we would have to take those two numbers, 0.089 and 0.0055, add those together, and you get 0.0945-ish, and that corresponds with choice C. All right, now on to the free response. A medical researcher surveyed a large group of men and women about whether they would take medicine as prescribed. The responses were categorized as never, sometimes, or always. The relative frequency of each category is shown in the table below. Here's our table. So one person from those surveyed will be selected at random. What is the probability that the person selected will be someone whose response is never and who is woman? So this is essentially asking what's the probability that their response is never and woman. So that's the overlap of never and woman. So that's 0.0636. Part 2. What is the probability that a person selected will be someone whose response is never or who is woman. So this is probability of never or woman, which is the probability of never plus the probability of woman minus the probability of the overlap, the probability we just calculated. So we can do that over here. The probability of never is going to be 0.12 plus the probability of woman is 0.53. That's right here and right here. But in those, we added in the probability of woman and never 2 times. So we need to subtract that out. And you get 0.5864. Number 3, what's the probability the person selected will be someone whose response is never given that the person is a woman? So probability of never given that they are a woman. Well, this is the probability of never and woman, so 0.0636 divided by the probability of a woman, which is 0.53. So right here. So it's a 0.0636 chance out of 0.53. So we would get 0.12 there. Part B, for the people surveyed, are the events of being a person whose response is never and being a woman independent. To show that two probabilities are independent or not, you have to compare the conditional and marginal probabilities. Since the probability of never is 0.12 and the probability of never given woman is also 0.12, they are independent. So again, let me reiterate, since the conditional probability, probability of never given woman, and marginal probability, probability of never, are the same, this implies that knowing the gender does not provide any additional information about the medical habits, and therefore they are independent. Part C, assume that in a large population, the probability that a person will always take medicine as prescribed is 0.54. If 5 people are selected at random from the population, what is the probability that at least 4 of the people selected will always take medicine as prescribed? Support your answer. You can't just write down the answer. You have to show a little bit of work. Now, we can do this entire problem in Desmos, and we need to make sure that we're writing down the correct information. So for this one, this is a binomial probability with n equals 5 and p equals 0.54. And we want the probability of x greater than or equal to 4. And in this case, you might add that x is the number of people selected that take their medicine regularly. From this point, we can just use Desmos. So we'll go up here into inference, go to probability distribution, drop down to binomial. We are doing 5 total trials with a probability success rate of 0.54, and then it's going to graph the distribution right here. We're not really worried about the distribution. We want to know the cumulative probability to the right because it's greater than or equal to 4, because it's at least 4. So we put in 4 and you get 0.241. You can click that and export it and get more decimal points. But if you go out at least 2 or 3, you would be good. It's 0.241. Now we could also calculate this by hand. The probability that x is greater than or equal to 4 is the probability of 4 plus the probability of 5, because you only have 2 options here. The probability of 4 is 5 choose 4 times 0.54 to the 4th, so that's 4 successes, times 0.46 to the 1st, that's 1 failure. Then the probability of 5 is going to be the same thing, but with 5 instead of 4. So 5 choose 5, 0.54 to the 5th, 0.46 to the 0. Where I got the 0.46, that's just 1 minus p. That's the probability of not getting someone that takes their medicine as prescribed. And then you would just add those 2 numbers together. Once you got those, you'd get the same thing, 0.2415. All right, guys, that's it. Hope that was helpful to you. Make sure you check out the PDF link below and try these problems on your own. Let me know in the comments below which of these problems was a real sticking point for you or a light bulb moment. Good luck on that AP exam.